right, so this is lesson 10. This is the one where we're actually modeling a sinusoidal function. So in general here, what we're trying to do is figure out what's the equation. In lesson 8, we did the equation from the graph. This is a little bit different. So let's practice, though, this with the graph. First thing I always want to do is identify my midline, because everything else happens relative to my midline. So my midline is going to be right here at, looks like 30 if I'm going from 50 to 10. And again, what I could do is go, well, it's max plus my min divided by 2. My max is 50, my min is 10. So max plus min divided by 2 is still going to give me that same value. Or I could also just eyeball it and look at where the max is. So this is my d value. So that's 30 right here. So I'm not doing this with a smartboard, so you'll have to excuse my writing and my slowness. My a value is always the same distance above and below my midline, which in this case is going to be 20. So my a value is 20 over here. And then it's going to be sine of, need my b value, which is again 2 pi over my period. So the next thing I need to look at now that I've got those things in place is find my period. I'm going to go max to max. It looks like this max is at 16. Looks like each of those notches is 4. So 20, 24, 28, 32. So that works. So this one's at 20. And then my next max is right here. Looks like 52, 56. So 36 looks to be my value there. I can check it right here too if I go from 8 to looks like 40. So that's a difference of 32 also. Or from 0 here to the next 0 going down here. Oh, look, that's also 32. So pretty straightforward. My period is 32. My b is 2 pi over my period. And my period is 32, so 2 pi over 32 is going to be pi over 16. There we go, pi over 16. Now the last thing I need to do is find my starting point. It's a sine value, and a is greater than 0, so it should start going up. So there's my value right there at 16. So t minus 16. We'll move it, translate it 16 units to the right, right? Okay, good. So same thing going on here, except now they haven't even given us the whole graph. They've just given us some information about the graph. So if we were to look through this thing, it is snail starting here at its midline, and we know this entire wheel is 50 centimeters. So if the entire wheel is 50 centimeters, it means that starting halfway up is going to be 25. So my d value, or my midline, is going to be 25. And then as it turns out, it's going to go above 25 and below 25, 25, because it's going to go from 50 to 0. Again, the reason for that is that the diameter of my wheel is 50. So right now here, I can go, okay, this is going to be 25. This is also going to be plus 25 way over here at my d value. And those values are actually generally fairly similar in lots of real-world application stuff. Then I need to get my b value. So it's going to be a sine here. My b value I need the period for. Now, this is where it's a little bit tricky, is that I got to go around and find my period. I've got to figure out my period. It's not expressly stated. They did tell me it takes 4.5 seconds to hit the ground. And they also told me that 10 revolutions per minute. So I can use both of those informations to get the values that I need out of this thing. But to start off with, I am going to take the just the 4.5 seconds to hit the ground. When I do this in class, that's the piece of information that students always lock on. And it's a useful piece of information. So if that's the piece of information that I'm going to be working with here, I can go, all right, if this is 4.5, I can see of the 4 pieces of this graph, that's 3 of them. Or the wheel has gone 3/4 of the way around if it's here and then ends up down here. So it's gone 3/4 of the way around, and I can go 3/4 equals 4.5. Now 4 times 4.5 is going to be 18, so 18 divided by 3 is going to be 6. So if I did that, each of these little pieces is 1.5. And then each of those 3 pieces, if I added on one more piece, that's going to be 6. So my entire period is 6. I could also get that from this 10 revolutions per minute. If there's 10 revolutions per minute, so 10 revolutions equals 60 seconds, then 1 revolution, divide both sides by 10, equals 6 seconds. So my period either way is going to be 2 pi over 6, or pi thirds. So 2 pi over my period is going to be my b value, which is then going to be, it's funny that I can draw pi fairly nicely here, but not, 6. That's going to be 3 for my denominator. Ooh, terrible. And then my variable. And there's my formula there. Similar thing here. We're going to basically do the same thing. Now, thankfully, they've given me a table here to help me identify it. They won't always give you that. They could just give me this textual information, and I should be able to figure it out. So first of all, diameter of the wheel is 76. Max height is 80, which means that at its minimum, it's actually 4, right? So they brought this in here. The people had to go up a little ramp, obviously, to like get onto the Ferris wheel here. So it starts at 4 would be the minimum. And it takes 9 minutes. So it's going to get back to 4 here after 9 minutes. That means at 4.5 minutes, it's got to be right at its top, which we already decided was 80 meters, which is really, that's a pretty solid Ferris wheel. 80 is a big distance to get up there. So anyway, it's going to do something like this. Okay, excuse how not smooth that is. Now, determining the equation in this part, I'm going to go, okay, well, my A value is, well, always start with our D. My midline here from 80 to 4, 80 plus 4 is 84, divided by 2 is 42. So my midline here is going to be at 42. And again, those formulas are really handy if you're the kind of person that likes formulas. Max plus min divided by 2. So that's that. So my D value, 42. Similarly, my A value is max minus min divided by 2. So 80 minus 4 is 76. 76 divided by 2 is 38. Now it's going to be a cosine graph because the equation says so. Again, there's nothing that makes it cosine or not cosine. Although if we had it be a negative cosine, man, we'd be loving life because I could just start at my minimum and not even have to use a C value. Because it's a positive cosine, I'm going to need a C here. So the next part I need to figure out is my B value, my period, which we already know is 9 seconds. Sorry, 9 minutes. But so that's going to be 2 pi over 9. So 2 pi over 9. And again, we graph everything in radians for reasons that will become significantly clearer in calculus. But for now, just take that it is true. So this is going to be t minus, and I have to distribute it. Now I need to be a positive cosine, so I need to start at my max, which is right here. So to start at my max, I just need to translate the graph over 4.5. It's going to be minus 4.5 here. There we go. Again, I apologize for my slow writing and messy writing. Now that I've got this done, now I just basically plug the things into my calculator. Clear all that out here. So 38 cosine of bracket 2 pi. Now I need to make sure I'm in radians before I go graphing, although it usually becomes abundantly clear when I haven't done that. X minus 4.5, close my bracket, plus 42. Now it helps to make my window look similar to this. So I'm going to go from 0 to 9 for my x and from 0 to 90 for my y. It's nice when they give you those values. You don't have to kind of figure them out or fumble around. And I've actually got that already in here. So look at me go. Just after saying make sure in radian mode, and I don't make sure I'm in radian mode. Let that finish off. So mode, radian. Let's try that graph again. Now that looks right. And the great thing is that with our calculators, we can be doubly sure that we've done this correctly just by testing our values, right? Just by making sure that we have, in fact, got the values that look right and give us the kind of graph that we're expecting to see there. So, anywho, rocking this through. That's our graph. Now, what it's asking us for down here is how high is the cart 5 minutes after? Well, my h values are my height values, so I'm just going to do my y's there. Y equals 5. Oh, no, sorry, 5 minutes. 5 minutes is a time value, so it's an x. So I'm just going to go in here and go second calc value at 5. So it's 77.7 meters high at that point. When does the cart hit 10? Well, I'm just going to go in here, go y equals, put my y2 at 10, and graph it. Now I'm just going to find my intersect points there. Second calc, intersect, curve 1, curve 2, and guess, let's just go like 1. I don't know what the actual value is, but it looks pretty close to 1 there. 0.81. Now to the nearest second, that's point minutes, cheapers. So 0.81 minutes. Now I don't want to have to round that. So what's great is that my calculator doesn't force me to. I can just pick those values out here. So go back to my calculator, second quit. Again, if I type my x, it remembers the x value that it just created. Again, as we've already pointed out, that value is in minutes, which we don't want. So I'm going to multiply that by 60 seconds. So it's going to take 49 seconds. 49 seconds to get there. All right, hope that helps. Again, as always, if you have questions, come in, get extra help. Happy to assist.